Hi everybody, good afternoon. The next room here is a crypto system learn public key cryptography concept by analyzing data. This is but previous Hacktify battle. If you did it, there's a couple of them. They released yesterday, a couple of rooms. Um, they said we intercepted the communication between Cypher and some three associates, Rivest, Shamir, and Adelman. We were only able to retrieve a file or they get secret key from a recovered file. They get the secret key from a recovered file. We have a Python script. This is cryptography. This it means calling a file called flag.py, and the name is the variable called flag or function, whatever it is in that file. Now there's it define a prime function. It use what exactly is doing. It look for a prime number and then add 2 for the next number. This is the Python one. This one just a normal generate a Python script, no, a prime with length of I think 1024. So this is fine. The problem is here. This is where the problem is. The Q, remember for RSA you have P, Q, and D, all these numbers. This is the standard, that's fine. The problem is Q. When this function call, it mean look for the next prime after P. That's what it do. It is doing. Let's practice it so understand it. So if we do that, yes, that's some explanation. For example, it said get prime. It's secure. It's just fine. This is secure generator randomly. It's a random prime pine of the bit with 1024-bit prime number. So that's basically you can say it's fine. The primal function, this function take a number of n and find the very next prime number after it it does this by starting at the next odd number and incrementally by 2 until prime is found. So basically this is primal. Let's test it. For example, if I do what's another prime number, let's say 19. No, it doesn't do some kind of randomness, it just go to the next one. You see, it doesn't. So basically this is what the flaw here in this logic. So the prime it go to the next one. So we know in RSA you multiply these two, but the problem is because P and Q are next to each other, so it means we can guess them. The public modulo n is calculated. This one is the standard at 65537, and then we have the decryption, the flag. En, the flag is converted to an integer and encrypted, producing the ciphertext. And already I can test that. For example, where is it? For example, I can do. For example, this is the original file. Remember this one. Um, this is the TryHackMe file. If you go there, let's make it bigger. So in my case, it worked because I put the flag. I put the flag. For example, I have a flag head minus C7, the flag py. There is a file where I put the flag on it, so the original flag. So that's why the order, my order script work, and you can see it's the same as TryHackMe. It give you the encryption, it give you that. So it's basically this script. If you know the flag, you can run it. So next, so that's fine. So you can remember they are different every time you run it, because that's how cryptography work. It's the same ciphertext, but the ciphertext is different. It runs differently. You can see this value is not the same as this, but that's fine. It's not an issue. When you decrypt it, you get the same thing. So now, so what that mean after, because P and Q next to each other and they are prime, so it mean they are closer to the square value of n. Remember, they give us n, the value of n that we need to find P and Q, where P multiplied by Q equal n. So basically, since P and Q are extremely close to square n, because when you multiply them, you get close to n. So we don't need to search all possible factor of n. We can simply start searching for prime factor in the immediate vicinity of square root of n. Because square root of n multiplied by square root of n, we find n. So P and Q would be very close to each other in that region. So the strategy to find the flag is as follows. Calculate the square root, find the integer square root of the public modulus n, let's call it s, search for p since p square is equal to q, then the prime p must be slightly less than s. We can start searching downward from s. Since primes except 2 are odd, we only need to check the odd numbers, and if we found it, we go back to normal RSA encryption and we decrypt our message. Now the script that do this, if we want to do this, is this one. I don't know what I called it, or the solution is this one. So basically that's the n, the one 5, we have the c, so the n, we have the c, then he go to find the p and q. After you find it, this is a normal encryption RSA, then of course you get to print the flag, and then I want to test something, because I want to get the encryption key to private key as value. Let me show you what I mean about that. So if I run Python 3 or the solve, you see it give me it get all the information that we're looking for. So you get a P, you get a Q, where the factorization is successful, and then we get our decryption the text. But now let's decrypt in different way. Because the reason why I convert it to a PEM file, so the encrypt because I want to use Cyberchef, because we have RSA here, we can test this decryption here. But before we do RSA, now we have one little problem, because this value of the cipher, it's a decimal. If I tell because this is the encryption text of the what is not pasted? No, it's not pasting. What's wrong with you? Okay, Control C. Let's take any spaces. There is no from decimal, because if I tell it, for example, now decrypt RSA, this is not hex. I say decrypt and I get the key. Where is the key? We got the key, this one. If we copy this, now if I go there, see now it error get message length is invalid, because this is not a decimal value of it. Now I don't know, because when I look for decimal here, there is only two decimal. Oh, there is from decimal. Why I didn't see it before? So we can do this from decimal. Why are you red there? So you only have semicolon, colon, line feed. Why from decimal? It's in red. Data is not valid byte array. I thought we can do it. It's not space, not comma. It doesn't have. You see, that's my problem with it. Even from decimal, because this is decimal, need to convert it to hex. The problem is I'm having problem with it. I was playing around it. One way it is work for me is this little script of Python. If I give it there and tell him to convert it to hex, look the value we get now. If I run this script, now we get the value of hex, but I don't know why this from decimal doesn't work. It's only space. So what? You only do he accept numbers. So why he has a problem with my? So suddenly now 23 fine. Then suddenly line feed. Now suddenly. Okay, so if I do this, convert it to hex from there, so we can experiment. Sometimes it's good to experiment. So let's do kill this. Now we have that, so I can get hex, for example, from hex. Because now I convert the encryption from decimal to hex. Now I can do this. No, not you, not you. This one. Uh, no delimiter none. Okay, row, and then you can see the flag. That's the flag. TryHackMe is just some small amount. So I don't know if we can find a way that the decimal, but this is the if you want to decrypt now like that. So you can get the decryption because we have the key now. You can decrypt anything, and that's why I said to you. Remember when I said to you, I got the original script that. Python order the one because I create the flag there. Let me show you what I did. That's the flag, the same as TryHackMe. So if you run the file python uh, uh, order.py, now you get the encryption for that. Remember the encryption change each time. That's not a problem. You should be. And now we need to go to decimal. Get the hex quickly. If I do that. Let's kill this one quickly. Oops. If I put C equal and then I get this value, and now if you come there, what's going on now? I don't know, guys. Sometimes works, sometimes what's going on? That's well, the keys should be the same. URI error, malformed URI sequence. What's URI? I don't know the hex. What's wrong with this hex? What we got? This the C value. This is the N. Is there any spaces or something? No, there's nothing about it. So why is not 4C? That's a gated. That's a value of the number. It's in hex. So malformed array sequence. The key, it's the same. Did we touch the key? No, key doesn't change. I don't know, guys. Well, that's nice. So if we use the, I think we need to create a new one, something like that. If I so it seem that key is for what we did. So if I go to my hacks again, if I do C equal, I give it the one of TryHackMe that we did the message of. So if I copy now this one will work. So no, what happened to the other one? This one somehow it work. Any case, guys, so yeah, I'll share I'll share the script so you can play with it. But any case, the idea, as I said, is the whole point is because the second value of Q wasn't far enough from the P, it was closer to each, and that's how the lesson of this room. That's why he said learn public cryptography concept, analyze data. That's exactly what it is. So yeah, thank you guys very much. If you have a question, let me know, and have a good weekend.